Good morning, grade 9. Today, our lesson is going to focus on multiplying and dividing polynomials. So the first thing I'll note is this is kind of like part 1 and of a two-part concept. And with multiplying and dividing polynomials, all we have to really remember is some of our multiplying and dividing rules regarding the positives and negatives. So I'll kind of write those rules on the side just for reference. A positive multiplied by a positive, still positive. A positive multiplied by a negative, or a negative multiplied by a positive, those both come out to be negative. And a negative multiplied by a negative, that comes out to be a positive. Those are our rules. We are quite fluent with that, but just keeping it in mind up here can be useful for us. So let's begin with multiplying a polynomial. And for the most part, all of the things that we're going to multiply by are constants. So I'm going to bring up that word again. What does constant mean? It means kind of like a regular number. Regular number, no variable involved. So regular number, no variables. We like foreshadowing, I suppose. So that's what we're going to be multiplying and dividing by today. So let's do our first example. We'll do x squared minus 3x plus 2. And before I get too heavy into the symbolic nature of multiplication and division, I'd like for us to draw the algebra tiles that would represent this expression. And so I'll do that over here. So I have x squared it's positive, so it's shaded. A negative 3x and a positive 2. And this will kind of help visualize what we're doing for multiplication. But for the most part, I want to have us understand that we're going to multiply this whole thing by something. And the thing we're going to multiply it by is 3. So let's multiply by 3. All of this. And we're going to start with the 2, because we know how to multiply 2 by 3. I just have 3 groups of 2. So three times 2 is 6. So now I have 6 of the ones tile. And we can kind of just account for everything. We just have to remember we're multiplying every one of these by 3. So when we multiply by 3, when we do that let's multiply by 3, we get a plus 6 for the constant term in the end. We're multiplying by a constant because it doesn't have a variable associated with it. And what our constant term of our polynomial was, I hope you're with me on that language, it was 2. I multiplied it by 3, and I got 6. 3 groups of 2 is 6. So let's do 3 groups of the 3 negative x tiles. So I have one group here. So now I have, well, how many altogether? I have 9, and they're all negative. So in the end, I have negative 9x. Okay, and then how about this? Let's 3 groups of that x squared tile. And so I have 3x squared. And so my polynomial after multiplication by 3 becomes 3x squared minus 9x plus 6. Now, I do want to highlight, because we're not going to draw tiles every single time, it's just useful to see that our end result is really just grouping or dividing our terms. Grouping for making groups for multiplication, or dividing by dividing. So let's just kind of explore, well, what's 2 times 3? That's 6. What's negative 3 times 3? Well, that's a negative divided by or a negative multiplied by a positive, still a negative number, and 3 times 3 is 9. So that's usually how I do this, is I say, okay, it's going to be negative, and 3 times 3 is 9. This is positive multiplied by positive. 3 times 1 is 3. And that's really all we're doing here. So with that, let's kind of move into how we write something like this, because we don't do this. How we'll see this written is we'll have our particular expression. Usually that's going to be in brackets. That will symbolize I'm going to do something to this whole expression here. And what I'm going to do is I'm going to multiply it by 3. So sometimes we'll see it written like this. 3 times all of this. If I use this symbol for multiplication, it gets a little bit confusing because I have a multiplication sign and then all these x's, and that again is just confusing. So we use a different symbol for multiplication. Other times we don't use a symbol at all because we're lazy and we want to represent this by writing as little as possible, and so most of the time we'll see it written as this. 3 open bracket x squared minus 3x plus 2 close bracket. And so this represents that we are multiplying. So 3 times x squared would be 3x squared. 3 times negative 3x would be negative 9x. And 3 times positive 2 would be positive 6. So that's usually how we write things. Let's go into a couple of examples. Two x cubed minus 6x multiplied by 7. Okay, so this is another way we can see this being written. It just means the same thing. So I'm going to multiply everything here by 7. So, I mean, I also want to recall, like here we just did negative 3 times 3 to get negative 9, and then associated that with the fact that it's not just a normal number, it has the x variable in there. So we can do the same thing here. What is 7 multiplied by 2? Well, that's 14. And it's not just a regular 14, it's 14x cubed tiles, which we don't actually have a tile for. And that would be 7 multiplied by the 2x cubed. Next up, we have 7 multiplied by negative 6. Well, 7 times 6 is 42, and it's a negative 42. And it's x tiles, or it's the x variable versus a number, or versus the x cubed. variable term. These are different terms now. So I'm hoping this is kind of making sense. So that's kind of what we get in the end. Now, what's very, very important to understand is that these two things, these are the same. They represent the same values. So 2x cubed minus 6x times 7, when you kind of do that multiplication, you get 14x cubed minus 42x. And these two different expressions represent the exact same thing, just different ways of writing it. So that's our first example. Let's do another. I'm hoping that by just doing practice, I mean, eventually you guys will kind of catch on. Our next example is a negative 2 multiplied by x cubed minus 3x squared plus 4x minus 5. And so when these start to get like a lot of terms and I have to multiply by something, sometimes you'll even see me draw these arrows just to count that I know I'm multiplying everything. I just kind of want to make sure that I don't miss something. So negative 2 multiplied by x cubed. So what is the number that is implicitly written in front of this x cubed? Well, it's 1. It's 1x cubed there. So what is negative 2 times positive 1? Well, negative times a positive, that's a negative. And 2 times 1 is 2. So this becomes, this negative 2 times 1x cubed becomes negative 2x cubed. And I'm going to do negative 2 multiplied by negative 3x squared. Well, that's a negative multiplied by a negative, which gives me a positive number. So positive, what's 2 times 3? That's 6. And it's an x squared term. Okay. Next up would be negative 2 times positive 4x. Would be negative 8x. And next I have negative 2 times negative 5, which is positive 10. Because of that negative multiplied by another negative. And just as I go, I'm too ahead of myself, but I just want to make sure I get everything. And these two things are the same, so that these are equivalent to each other. So that really covers multiplication quite well. Division, on the next page here, division is going to look a little different. However, concepts are all still the same. I'm dividing by a constant, and let's just kind of get right into one of our examples. Let's do 2x squared. We'll just divide that by 2. So how would we write this? Well, we'd have 2x squared, and we divide by 2. And we can write this kind of a couple different ways. We can say, I want to take this whole thing and divide it by 2. And I'll see when I split these up, I have 1 in each group. So this is going to be equal to 1. 1x squared, because that's what's in each group, one of them. The other way we can see this written is 2x squared over 2. And that means the same as the line above. And often when I write it, I write it like so, and I have a 2 on the top, I have the 2 on the bottom. I'll often say those just cross out. and I'll be left with x squared. And the crossing out is the idea that they divide out by each other. 2 divided by 2 is very simply 1. And I often don't actually have to write the 1. It's implicit. It's implied. So let's try another one. Let's try 4x squared minus 6x. Let's also divide that by 2. So I draw the dotted lines to kind of symbolize that division by 2. And well, I can see what I'm going to have in each group. I'm going to have a 2x squared and a negative 3x in each group. So the way I kind of write that would be, the way I would write it is 4x squared minus 6x divided by 2. And this symbolizes that I'm dividing both of these things up here by 2. And so 4 divided by 2 is 2x squared. And negative 6 divided by 2 is negative 3x, which is also what I just mentioned I had in each group. And so these two things also, similarly to how we talked about multiplication, these are exactly the same thing. They just look a little different. So let's try another here. Let's try 2 examples. And let's try this out. So this represents 16x squared minus 32x plus 64. All of this is divided by 8. So I would just systematically go through each term and divide it by 8. So 16 divided by 8, well, that's 2. It's not really 16, it's 16x squared. But I can get the coefficient by just looking at the numbers that are happening here. So 16x squared divided into 8 groups is going to be 2x squared in each group. 32 divided by 8 is 4. It's not 32, it's negative 32. So negative 32 divided by 8 is negative 4. It's x as well. And then 64 divided by 8 is positive 8. And so this is how that simplifies. We'll do one more. Three x cubed minus 21x. Sorry, we'll do 2 more. Divide by negative 3. Okay, so 3x cubed divided by negative 3. Well, this is a positive divided by a negative, and I would say that 3 divided by 3 is 1. So I'm going to get a negative x cubed. Then negative 21 divided by negative 3. 21 divided by 3 is 7. It's a negative divided by negative, so it's a positive 7x. And that's what I'm left with. That's my simplified version of this division statement. Last one here. X squared y minus 8y cubed plus 12 So 14x squared y, that's going to get divided by negative 2. 14 divided by negative 2 is just negative 7. And I have x squared y. Next term, negative 8 divided by negative 2. That would be positive. So negative divided by negative. That would be positive 4y cubed. That's the particular term I'm dealing with. Next up is 12 divided by negative 2. That's negative 6 xy squared. And then negative 4 divided by negative 2 is positive 2. And that's my simplification. That will be all for today. Good luck, and let me know if you have any questions.